Hey makers, welcome back to HUB360 Embedded Sphere, your favorite tutorial series for embedded electronics and smart project builds. Today in part 2 of our Bluetooth controlled robot series. In part 1, we built a robot car and controlled it with basic directional commands. Now in part 2, we are adding backward motion and we are designing a Bluetooth remote control app using MIT App Inventor. No coding required. As always, every component in this project is available at hub360.com.ng, your trusted electronics store in Nigeria. Let's dive in. In this version, the robot can now move forward, move backward, turn left or right, stop at any time. We've also designed an app interface with dedicated buttons for each function. Tapping them sends a Bluetooth command to the robot. The components used: we use one Arduino Uno, one L298N motor driver module, two DC gear motors, HC05 Bluetooth module, two wheel chassis and wheels, and then power supply, 7 voltage batteries. We have jumper wires. Okay, connections: motor driver L298N to Arduino. Connect the enable A pin to D9 on the Arduino. Next, connect the in 1 pin of the L298N to the D8 pin on the Arduino. Next, we are connecting the in 2 pin of the L298N to the D7 pin on the Arduino. Next, we are connecting the enable B pin on the motor controller to the D3 pin on the Arduino. Next, we are connecting the IN3 pin on the motor driver or controller. Next, we are connecting the in4 pin on the motor driver to the D4 pin on the Arduino. Now we are connecting the motor A output pin of the L298N motor driver to the left motor. Now we are connecting the motor B output, the motor B output pin of the L298N motor driver circuit to the right motor. And here's the right motor. Next, we are connecting the 12V VCC pin of the L298N motor driver to the battery supply. So now we connect the GND of the Arduino to the GND of the motor driver. Next, we go to the Bluetooth module, the HC06 Bluetooth module. We connect the TX pin on the Bluetooth module to the D2 pin on the Arduino. Here's the Bluetooth module. We are connecting the TX pin So this is the TS pin, the third pin from the left. We are connecting it to the D2 pin on the Arduino. Then next, we connect the RX pin on the Bluetooth module to the D6 pin on the Arduino. To do this, we use a voltage divider to avoid damage to the circuit. And let's make a voltage divider. Okay, great. Now I made a voltage divider circuit. So we go on to connect the RX pin on the Bluetooth module to the D6 pin on the Arduino. This is the RX pin, second to the last on the left. So we now go on to connect our VCC on the Bluetooth module to the 5 voltage on the Arduino. So this is a VCC, the second to last on the right. Then we connect the ground on the Bluetooth module to ground on our Arduino. Important note, the HC05 RX pin is not 5 voltage tolerant. Use a voltage divider, a 220 ohm resistor and a 440 ohm resistor on the Arduino TX line, just as we did here. Let's break the updated Arduino code into sections. First, library inclusion. We include library. We begin by including the software serial library. This allows us to communicate with the Bluetooth module using digital pins D2 and D6. Remember, the Arduino has only one hardware serial port and it's used by the USB connection. So we use this library to create an extra serial port. Then the Bluetooth setup. Here we define pin 2 as the receive pin and pin 6 as the transmit pin for Bluetooth. We then create a Bluetooth serial object called Bluetooth. This object will be used to receive commands from the app. Then the motor control pins. These pins are used to control the two DC motors via an L298N motor driver module. Enable A and enable B control the motor speed using PWM on the Arduino. And then in 1, in 2, in 3, and in 4, control the direction of the motor. And go to the setup function. In this function, inside setup, we set all motor pins as outputs. Then we start serial communication for both USB serial monitor using serial begin 9600 and Bluetooth communication using Bluetooth begin 9600. Then the movement functions. Now let's look at how each movement command is handled. This function spins both motors forward with a speed value of 100, and then in move backward, the function reverses both motors, allowing the cars to move backward. Then we stop the motors. In this code setup, this simply cuts power to all motor control pins, stopping the robot. Then turning right, this spins the left motor backward and the right motor forward. The robot turns right for 350 milliseconds, then stop. Then we have the turn left. This does the opposite. It turns the left motor forward and the right motor backwards, making the robot rotate left. Loop function. This section constantly checks if the Bluetooth module has received command. If it has, it reads a single character and prints it to the serial monitor. Command and detection logic. Depending on the character received, F represents moves forward, B moves backward, S stops the motor, R turns right, and L turns left. These commands are set from our custom mobile app, which we built using MIT App Inventor. App structure and behavior. Lead speaker Bluetooth device selector. Before picking, lead speaker.element is populated with available Bluetooth devices. After picking, app connects to the selected Bluetooth device using Bluetooth client 1.connect address. 2. Clock 1 Bluetooth status checker runs in the background every few milliseconds. If connected, label shows connected in green. If not, label shows disconnected in red. 3. Disconnect button. Manual disconnect button. If connected, disconnects from Bluetooth, updates label to disconnected. Then 4. Movement buttons. Each button checks if Bluetooth is connected, then sends a character command. Forward button dot click sends F. Changes button color to green. Back button dot click sends B. Button turns cyan. Left button dot click sends L. Button turns orange. And right button dot click sends R. Button turns purple. Stop button dot click sends S. Button turns red. All these values match what the Arduino expects in its loop. Let's upload the code, power the robots with your battery pack. Open the app, tap the connect button to connect your HC05. Use the buttons to move forward, backward, left, right, or stop. Watch the robot respond instantly to every tap. And that wraps it up for part 2 of our Bluetooth control robot car project. You now have full directional movement, a custom remote control Android app, a reliable robot base ready for expansion. Stay tuned for part 3. Like this video if it helped, subscribe so you don't miss the next tutorial. Order your parts now at hub360.com.ng, Nigeria's go-to store for embedded hardware. Until next time, keep building, keep innovating. This is HUB360 Embedded Sphere, helping you bring your ideas to life.